Hi, exciting news coming through this week. Gyroflow 1.0 was recently released, and if you've not heard of Gyroflow, it's a software that allows you to stabilize your video footages using gyro data. Now, this is exciting because it came with two major improvements, one to the user interface, and also it allows you to render with GPU. Previously, renderings that would take an hour or two on the GPU now in Gyroflow takes just minutes. In this video, I'm going to go through the Gyroflow 1.0, the interface, and then all the available features and settings that it comes with, and then discuss that as well. Then at the end of the video, we'll actually go through the steps trying to stabilize a footage recorded with the Firefly X Lite FPV camera. So let's get started. Before we continue, I want to say a big thank you to this video sponsor, which is Experience Africa Today. If you're looking for drone stock footages from Ghana, high quality 4K 30 frames per second and above, make sure to find Experience Africa Today. Go through the available collections, free sections where you can download free drone stock footages. Find the link in the description, Experience Africa Today, to download some of the free stock footages available. Thanks for sponsoring this video, Experience Africa Today. So you go to the gyroflow.xyz official website. You'll have an option to download the latest release, which is going to be on the Gyroflow GitHub repository, the Gyroflow/Gyroflow. Over there, you'll find different releases for different operating systems. I am on Windows, and so I'm going to download the Windows one. I download it onto my machine and I unzip it. But before I continue, if you are a developer and you're interested in contributing to the project, you can see instructions related to how to download and get a local copy of it so that you can help with bug fixes or documentations or whatnot. The code is currently in Rust, unlike Python, which the previous version was in, and I think the Rust also helps with the improvement and speed performance and stuff like that. Now we have the software on our computer, we've unzipped it, we run it, and you're going to see a screen like this. Right off the bat, if you are on a dark mode, you're going to see a dark screen like this. If you're in light mode, you're going to see a lighter version. This is a complete overhaul from what we had in 0.3, which was in a tab form. So from one tab to the other and that. In this case, you have everything on the screen arranged nicely from left to right. And that's how we're going to go through this. The input video information section allows you to select the video file you're going to stabilize. Now, in the middle section, you have this giant space for previewing the video you've selected. When you select a video file, you're going to get the information related to it. You'll have the option to change the frame rate and also change the rotation. Frame rate is necessary depending on the video file and the frame rate it was recorded in. Sometimes you need to manually nail down the frame rate. That option is there. And then if your video was recorded maybe in portrait mode, you would have to specify that here as well. After that, we move on to the lens profile. Now, this is the profile that Gyroflow will use in undistorting your video. You can search through to find the one that matches your camera. I use the KhoPhi Firefly X Lite FPV camera, so I created that and shared it with the project as well. If you do not find your exact camera in the list when you search, you can create your own file using the calibration step. If you would like to learn about how to do the calibration, you can let me know in the comment section below. The lens profile is specific to the camera, the lens, the field of view, recording settings, aspect ratio, and a whole lot of stuff. And so it's very important you get the right lens profile so that you get out a video that actually looks like what you want. The next section is the motion data. This motion data can either be, a file that is embedded in your GoPro video or your Insta360 or Sony or whatever you have, or it can be loaded as a separate file, which is what applies in my case. So my drone records the gyro data using the gyro on the FC, and then I'm able to log it to a file. That file, the black box file, is what I use on the computer. I export it into a CSV and I can import it into Gyroflow, sync it up with my video, and then Gyroflow can use that data to process the information. The low pass filter is important so that Gyroflow can get a cutoff point. Gyro data can usually be noisy without filtering, and so this low pass filter is essential to reduce the frequency and give like a hard cutoff point. Any data or any info after that cutoff point will not be used, which will help clean up the data Gyroflow has to actually stabilize your footage. Typically the cutoff point is 50 Hertz, but you can, depending on what gyro you're using and the kind of recording it does, you might have to get a different cutoff point, either higher or lower. It's up to you to get the one that works best for you. Change the pitch value to match the angle between the camera and the flight controller. So if your flight controller was flat in default position and you tilted your camera at, let's say, 20 degrees or 25 degrees in the pitch axis, you would want to specify the pitch axis to be 25 so that Gyroflow knows in relation to your camera what the angle is, and that is what you specify as the rotation. If you did similar altering to the other axis, you would want to specify that accordingly as well. For FPV users using black box data with a camera tilt, you would have to change the pitch value to match the angle between the camera and the flight controller. The IMU orientation in most cases is automatically detected, but if your stabilization appears to be wrong in the wrong axis or whatever, you might want to adjust your orientation accordingly. This is something not to be worried about most of the time for cameras like the GoPro, because all of that is handled internally and the gyro data is recorded accurately. But if you have a custom setup where, custom whatever, you would have to put in the right IMU orientation in order to get the best results. The integration method, this is how Gyroflow is going to translate the raw gyroscope info and the accelerometer sensor readings to the actual orientations for stabilizing the video. So the available options are what you see now. You don't need to apply any integration method if you are using cameras like the GoPro Hero 8 or newer. If you're interested in doing something like horizon lock, you might want to look into the complementary filter. Now, by comparison, the Gyroflow option only uses the gyroscope and doesn't work when you're trying to do horizon leveling. On the left side, we are done going through the options available. On the right side, we have synchronization. And this synchronization is required between the video and the gyro data. You can auto sync or sync it manually yourself. It's up to you, which we'll get into and see how that works. First of all, we have the rough gyro offset. Now, if you recorded your video and the gyro data separately, what is likely to happen is there's going to be a mismatch of the starting points. In the Black Box Explorer, you can align your video with your gyro data, and then in here, whatever value you got from the alignment, you would put it in the offset to help Gyroflow know that the video aligns with my gyro data starting from this point in the video. If you start your video recording followed by gyro recording 30 seconds later, you're going to use 30 seconds at this point. The search size is the segment of the video that Gyroflow should find the most likely matches. Now, depending on your video footage, you might go with 10 seconds or anything less than that, and that should work for you, but you would have to play around with your videos to figure out how that works. If you're bringing gyro data from cameras like GoPro and stuff like that, most of the time their gyro data is very good. You don't need to worry yourself with trying to get a big search size. They should work out of the box. The max sim points is the number of automatically added sim points Gyroflow should do. Normally 10 is fine depending on the length of your footage, and so if you have a really lengthy footage, you might want to do more points so that the stabilization can be as accurate as possible. If you have a shorter video length, you don't need to do too many sync points. It's up to you, but that's something to keep in mind. For analyze every nth frame, this is something you very likely do not need to touch. It's only useful when setting the frame rate to skip a certain number of frames. It's necessary in cases where your footage is very likely high frame rate footage, which means the relative motion between two frames are not so much to matter in such scenarios, but for the most part, you don't need to change this setting. Time to analyze per sync point. This is how much time Gyroflow spends analyzing a particular sync point to get the best match. The default is typically fine, and so you might just leave it. The optical flow method, currently the options are OpenCV, which is typically faster and the preferred, or Arcades. For the offset calculation method, there are two options available. The essential matrix, which estimates the relative role, your pitch of the angular rates between each frame, and then correlates it with the gyro sensor data. And the second option is the visual features, which estimates the gyro offset such that the tracked features move the least between frames. So these are the available options. I'm not going to pretend I understand the mathematics behind how this works, but you might play around with the different options to see what works. Considering now we have GPU rendering, you don't have to wait a long time to get the video exported to play around with different settings. We have the low pass filter. Now this is something you really need to change, but that option is there. A low pass filter for the video motion that it's going to stabilize. So the show detected features or show optical flow, it shows the motion in the video player during the playback. Now it's time to look at the stabilization section. After grabbing all the settings from the earlier steps, this is where we are going to specify the stabilization algorithms, the different look for the stabilized video. So we have the field of view, we apply a scale to the field of view. If your field of view is bigger than 1, you're going to have like some top or down bars for your videos, so keep that in mind. The available stabilization of algorithms are no smoothing when you just want just the undistortion to be handled. We have the plain 3D, which is a general purpose smoothing algorithm. You can find a link in the description for how the algorithm works with this smoothing. If your camera has a lot of rapid camera movements, this is not going to work well for you. Then we have the velocity dampened. This decreases the smoothing during lots of camera motion in order to avoid the image moving out of frame. We have the dampened, velocity dampened per axis. It's similar to the dampened, but then with individual roll, pitch, yaw, smoothness control options for you. We have the lock horizon. It keeps the horizon lock, which is a feature you can find in some cameras like action cameras, the Insta360, you find it in GoPros. It works best for flight without fast rotational movements since some gyros can be maxed out, so that's something to keep in mind. And then we have the fixed camera, which points a virtual camera fixed place in your video footage based on the user-defined direction. So the use case for this can be debugging or tweaking your sync and stuff like that. We have the crop section, and this crop is important because during stabilization, depending on how it's stabilizing, it will have to zoom in so that there's a bit of a wiggle room. You can select the no cropping, which is going to remain at the user-defined field of view throughout the entire video. You can do dynamic cropping as well. It adjusts the field of view to hide any borders or any black bars that show out throughout the video. And then you have the smoothing window to indicate how smooth field of view changes is in terms of the cropping, zooming out and zooming in kind of effect. And then the static crop with field of view of 1 will be the field of view at which no edges are visible throughout the entire video. We have the rolling shutter correction for cameras like the GoPros and Firefly and Insta action cameras in general. Rolling shutter is not an issue, but if you're recording with a camera that requires such kind of correction, this is the option for you to fix the rolling shutter issues with your camera. Then finally at the export section, it's fairly explanatory on its own, and you can just hover on the tooltips available to read what info is available there. By default, the resolution and bitrate are selected according to the input file you selected. So if your input was, let's say, 100 megabits bitrate, you're going to have this also dialed in accordingly for you, along with the output size. And then you can select if you want to use GPU rendering, which is one of the biggest, improvements to the version 1. Rendering GPU, if you are on NVIDIA, it works amazing. And you can decide to omit exporting audio. I like to disable the audio because that drone blade sound is noisy. When I do that, I just clear it off. Then the advanced section has what resolution you want to preview in the big space you have in the middle, what render background you want to use. And this render background is regarding if there are black, sections behind your footage, assuming you tweak with your field of view, what it should show. And then select your theme, your language, but yeah, anything experimental for those of us who live on the edge, we like to click on it. So that has been the overview of the Gyroflow 1.0 release that came out recently. Those are the features that are in it. That is how the interface looks like. At this point, let's see how to stabilize the footage within the next few minutes and actually see how all of these settings come together and play together to stabilize your footages as well. So let's get back onto the PC and actually stabilize a footage. Okay, so now back to the PC, and forgive the sound coming through because my laptop is working at full throttle. But we select the video we want to use on the left side. We pick the video. In this case, I'm going to pick this shot. And then the lens profile, we search for the one we want. Then we select the related motion data or the gyro data. If it comes already with the camera, it's going to automatically pick it up. When it comes automatically with the video, it's going to pick it up, so we don't have to worry about that. Specify the low pass filter, which in this case, I'm going to set it to 50 Hertz. Specify the rotation, which is going to be 15 degrees. And then I go with complementary, which is the default. Then I have the auto sync, which based on my black box explorer, I know this is the offset of when the video gyro data started recording in line with the video. And so I indicated here accordingly, specified my search size to be 10 seconds, and then the maximum sync points are 10 in this case. Under the advanced, I don't need to worry myself with any of these settings. I'm going with the OpenCV using essential matrix, all of that, show detected features and show optical flow selected by default. So moving on to the stabilization, field of view is 0. I'm going to use the plain 3D, which is the default stabilization algorithm, but like we discussed, there are different options you can choose from. We specify the smoothness to whatever matches our taste best, and then we select the dynamic cropping. Then we put this at, say, 4 seconds. You can enter the values in it directly if you want as well. We are not dealing with rolling shutter because it's from the Firefly X. There is no rolling shutter issue with it. We are exporting in X265, which is HEVC, and we're going to export in the same dimensions as what comes in, and then the bitrate, what the recording comes with, is 86 megabits per second. We're using GPU and then disabling the exporting of audio. Before we export, let's take a look at the graph we have here. So Control scroll to zoom in on the horizontal, and then Alt scroll to bring it to increase the height of it. This is going to be essential because when we do the auto sync, the Gyroflow is going to pick the sync points automatically for us, and those sync points are going to show on the timeline here on the graph for us to get to see exactly how the syncing tailored to the gyro data we have. And if the syncing is not good enough, we can manually add it ourselves. We can go back to adjust the auto sync features, the search size, the number of sync points, and go in the advanced section to tweak things to match our taste. But if the syncing is done and is good enough, we shouldn't have any issue with the syncing, and it should fall in line exactly with the graph we have here. The details satisfied with it, we can just go ahead to start exporting our footage. This is the place the video is going to be put, which is exactly the same folder as where we picked it from. So we click on export, we wait for some time, and then the exporting should be done. If you are rendering on GPU, it should be done within the next few minutes. The UI shows you the minutes left, the percentage done, and that is super useful. Now, with all that done, that is how to go about using Gyroflow. If you want to learn more about Gyroflow, there's a link in the description. You can find it and join the Discord server where you can ask questions as well. If you have any questions too, you can leave it in the comment section below and I'll be happy to take a look at them. Those I cannot answer, I'll definitely forward you to the Discord server where the actual developers are who know and understand it better. But yeah, that is how to stabilize footages. You'll find a link as well going to FPV Africa where I have some of my footages stabilized using Gyroflow and the side-by-side review of it. You can also check it out on FPV Africa. Thanks for joining me in this one. My name is KhoPhi and hope to talk to you in the next one. Bye.